I'm sure that most of us we are familiar with research in one way or the other, and in whatever form it might be, whether it's a quantitative research or qualitative, or whatever approach we use. We know that before we can go into analysis, there must have been a set of data collected. So before you start your analysis, you must understand your data. And that is what we are going to look at this morning. So first of all, before any analysis could commence, of course, we have different forms of methods of collecting data. There are some that are qualitative methods and some are quantitative. Some, they are just observations combining both quantity and quality. And sometimes you do document review, and sometimes it's opinion poll that you use to collect your data. So whatever method you use to collect your data. So there are various ways of analyzing those data you have collected. But in this training, you're going to focus on quantitative methods. And if you want to deal with quantitative method of research, that means you have collected your data, maybe through survey, it could be interviews, it could be experiments, for some that are maybe those who are in science or other fields that may not necessarily need a survey. And it could also be like records, maybe like financial records or performance records, maybe business performance and so on like that. Possibly those who are in accounting or in business or economics also. So you have collected your data. Now, whatever data we have collected, either survey or interview or record or experiment, they are either primary or secondary. And when you collect a primary data, it could be quantity or quality. Quantity, I mean quantitative, and quality means qualitative. So, and primary data implies you are the one that collected data by yourself, and it's for the purpose of the research that you have at hand based on your research questions. And secondary has to do with when the data is already available, but you find it useful for your study. You find it, relevant in achieving the objective of your study. So that is secondary. But then there are pros and cons of using either of the two, using primary or using secondary. So if you are using primary data, of course, there are some advantages of it. Of course, you know that the data is yours and it's original. It's directly relevant to your research topic. And it addresses the current issue at hand. And it gives a realistic view about your study. Not only that, it gives opportunity for you to choose the kind of appropriate research design for your study. And of course, you can cover as many variables as possible. But then it takes a lot of time. It requires a lot of effort. And also, the data collection itself, it could be very expensive. So that is one of those are the advantages of primary data. Then for you to have a quality data, you must have a trained and experienced, data collectors, like field workers that go out to collect the data for you. And if it has to do with experiment, of course, it has to be something you do by yourself and you are there. Because I know that for experiment, it will be difficult to say you want to use the secondary data. You have to do it by yourself, do the observation and do the recording. And also, another disadvantage of it is the risk of small sample size, especially when you don't have funding for this study. And of course, if it's individual research, it has the risk of small sample. That's the disadvantage of primary data. That is the data you collect by yourself. Now, for secondary data, it's the data that's already existing and is collected by a third party, and sometimes could be by you. It could be that you are the one that collected it, but it's not for this current study. and sometimes it's collected by a third party, and you now find it useful in addressing the objective of your research. So this kind of data, they have the data you source from another, you get from another source, has its pros and cons as well. In terms of the advantages of using secondary data, it saves your time and effort, and then you could have access to a large sample size. And most of the times, secondary data that are collected by a third party, maybe by an organization, they are likely to have expert touch, and so you could be guaranteed of the quality of the data. And also, it gives you a frame of research direction because you already have the variables, you have the data, you know what is in that data set. So it gives you a direction of where you are going right from the onset based on what you have in the data, because the real sense of it, you can't go beyond the data. And you can carry out a very robust statistical analysis, but it has some disadvantages. And number one disadvantage of it is it could become obsolete. If the data has been collected for quite some years or for quite a number of time, for a long time, to what extent can we say that data is still relevant today? So, or for in the current study, so that may be a serious disadvantage of using secondary data. And also, being a third-party data, it may not be reliable sometimes, because not all secondary data are reliable. So one must be careful and must be conscious of that. And also, sometimes the data or some part of it may be incomplete. And also, you might have issue with authenticity and copyright issue on that data. So those are things to take care of or to be aware of when you want to use secondary data. And another disadvantage of using secondary data is the limited number of variables that you have in the in the data set. You might have a very sound and good research idea, but since you are using secondary data, you are limited to the number of variables available in that data set. So you might not be able to go beyond the variables available in the data set. So that's another disadvantage of using secondary data. And there are a good example of such a data. And the demographic and net survey is one of the examples of secondary data has been found very useful. And multiple indicator cluster survey is another one. Malaria indicator survey is another one. PMA and many other secondary data. There are some, maybe from the World Bank database. It could be projected data from United Nations and other, organizations that have, large-scale data. So your sources could be all those. The data in those sources could be global observatory, global observatory, and being documented by WHO. So grab all those sources as your secondary data source. Now, before you proceed in your data analysis, so now you have your data. Maybe it's primary, maybe it's secondary. Before you proceed, there are things that you need to do. And first of all is to understand your data. You need to understand your data, run through it. Even if you are the one that collected the data, you still need to have a proper understanding of the data, not in terms of the variable. Since you are the one that collected the data as a primary data for your study, so you need to, first of all, understand how the responses are in that data set. You are aware of the variable, but how did the respondents respond to the questions being asked? Or how do the data look like? So for you to do that, and before you start your analysis, you need to first of all do a kind of data curation. and that has to do with you converting your raw data into a usable form. It's not all data that are usable the way they are. So you need to do some manipulations, you need to do some adjustments, some transformations. You need to work on it first of all. So for you to study your data, number one, you need to identify the data, your variables. Identify what variables are in that data, especially when you're using secondary data. Know each of the variables and know how they are measured. And so, as part of the way to understand the data, you need to do a kind of data cleaning. For you to do the data cleaning, you might have to run through the frequency distribution of the entire data set, especially the ones you know that you'll be using in your study. You do a kind of you run a kind of frequency of it for you to know whether there are non-responses, to know whether there are inconsistencies, are there some wrong entries, are there some outliers. Sometimes, let's say you are carrying out a study and the study addresses adolescent. Adolescent, let's say you are defining your adolescent as individuals from age 10 to 19, but in your in the data set, discover that there are some individuals of age 9 or age 20, 24, and so on like that. That is a wrong entry. That is outside your study. Your study is not, that's outside the scope of your study. So you want to check for inconsistencies like that. It could be that the individual entered a wrong, age. So I'm just using age as an example. Then other responses too. To check for inconsistencies. If an individual says is like say 15 years old, and then you are asking for the number, the age of the children of the respondent, and the respondent says my first son or my eldest child is 10 years old. That's an inconsistency. Remember, the person is saying I'm 15 years old and my eldest child is 10 years old. So does it mean the person gave birth to that child when she was 5? So inconsistencies like that. So you need to check. So you check, run the frequency, and then you also do some cross tabulations to see how the variables interact, how the responses are consistent, with each other or with one another. So you need to do the data cleaning. You remove all the outliers, and sometimes you might not outrightly remove. Try to look at what existing variables you have, the responses of the respondent in the existing variable. In the previous responses, look at it, and then in relation to this current variable that you have problem with, you might need to look at it, and then you make the correction. So those are things to do. There are a lot of things to do in the course of cleaning your data and removing the inconsistencies. So in the case of non-response, maybe you have like missing values. There are ways we deal with missing values. Where this training is not going to cover that. There is a science of missing value analysis itself, so we won't be able to go into that in this training. If we have opportunity, we can look into that next time. So yes, you have tried to you have tried to do your data cleaning. You look at non-responses, inconsistencies, that you have tried to deal with them. The next thing you also do is to also look at the various variables. How are they measured? If it's a primary data, you already know how it was measured. Of course, you designed the questionnaire, you designed the instrument to collect the data. So you know which one is numeric, which one is categorical. Numeric are variables that take numeric values. That means the responses that you have for those variables, they are numeric. A good example is that age, and you report the age maybe in year. And in some cases, if you're dealing with children, you might report the age, especially under 5 children, you might report the age in month. So you look at your variable, is it numeric, is it categorical? So for categorical variable, a good example is say the gender, that one is male, female. or marital status or level of education, your categorical variable may be ordinal, it may be nominal. But then in your data set, depending on what software you are using, the statistical package you are using, you code those categories. You don't enter male and then you type it as a string variable. When you have it that way, you will have to do some transformation or some conversion of those data that you have. You need to convert them. If you leave them as string, then you're going to have some problems when analyzing, because string variables, when not coded, for example, if you have male starting with an uppercase and you have another male starting with a lowercase, they are different. There are two different responses. That is how statistical software will look at it. Look at male starting with an uppercase of a capital M now. So that kind of a variable that kind of a response is seen as different from the one that starts with lowercase. So that is string variable. So you need to understand this and recode your string variable if you have any like that. String variable are just texts, maybe a combination of text and numbers sometimes. So you recode them into categories and you give them a code. So the fact that you give them a code, maybe you give male 1 and you give female 2, does not mean female is greater than male. Does not mean it's 1 and 2. It's actually, those numbers are just used to categorize or to designate the various responses. So it's not a true numeric variable, it's categorical. So, but for numeric, the number you have, it's exactly what it is. So if you enter 5, it is 5. The 5 is not representing anything. That's numeric. So we need to understand that. Now, another thing you do when you are trying to identify or to clean your data and trying to study your data is you also need to understand what are the levels of responses that you have in that data. Is it binary? Is it nominal? If it is binary, maybe just yes or no response. You need to understand that. And is it nominal or multinomial, that you have multiple categories of response? Take for example, using marital status, just using a very handy example. It may not be like that in your own study, in your own data. So let's take marital status as an example. So you have single, married, divorced, separated, widow, and so on. That's more than 2 categories, unlike just yes, no, which is binary. So you need to understand all those all of that, numeric, and the one that is ordinal. For example, level of education, we see that as also categorical, but it's ordinal, because someone that is that has no education, or someone that has primary education, we could say is better off than, in terms of education now, is better off than someone with no education. And someone with secondary education is better off compared to someone with primary education. And same thing for tertiary. So another thing you need to know is who should respond. You need to know that who should respond to your question. And then you also need to match the total responses with the total when you are doing your data cleaning. So another thing you need to do before you start your analysis is to do data diagnosis. Whatever statistics you want to use, all statistics have to do, they have some assumptions. Even some non-parametric, they still have some assumptions. So you need to do a kind of data diagnosis, check for distribution of your data, the ones that are numeric, the ones that are categorical. Try to check. There are some situations where the assumptions are violated. So you need to understand all of this. So you need to do kind of data diagnosis before you start data analysis. You can't jump into data analysis after collecting your data. You need to do quite a number of things. So as I've been mentioning. And then another thing you also need to do sometimes is you might have to do some data transformation, like generating new variables from the existing ones. I've seen instances that people analyze their data. They just analyze the questions just the way they were collected. They analyze the questions rather than, making some meaningful analysis or meaningful transformation of the questions that they already have. So you might need to generate new variables from the existing ones. Sometimes you combine variables, like developing a composite score, or you are developing a construct. There are procedures used for you to do that. When you are developing a composite score, you might just maybe do some additions, or you find mean of a number of variables depending on the responses there. And in some instances, you might develop a construct using some statistical techniques, like using exploratory factor analysis, principal component analysis, and what have you. Now, also, you might have to do a kind of recoding for some variables, depending on how the responses look like. For instance, if you collect your data and you discover that some responses are the responses in some variables are too few in some categories, they are too few, you might have to do a kind of collapsing, or you recode, you can merge. So all of these, they are very important, and they have to be done when necessary and as deemed fit. I will still be talking about some of those things later on. Now that you have run through your data, you understand it, you have done the data cleaning, the next thing is, what analysis should I do? What kind of analysis is appropriate for my study? The analysis that you carry out on your data depend on quite a number of things, and they are very important. If there is a violation or there is a mischoice or wrong choice of analysis, you might not be able to achieve your research objectives. And so number one thing that you are going to consider before you choose a particular data analysis method or statistical test that you're going to use is, what is your research question? Your research question is number one thing you need to consider. What do you want to achieve? So your research question or your hypothesis, if you have one, determines the kind of analysis that you're going to do. If your research question is to know the difference between a set of, maybe a particular variable and another, or to examine association, or you want to know how a variable influences another, then the kind of statistical techniques or kind of analysis you are going to do is different from someone who wants to know the impact of a particular intervention on the study sample. They are two different kind of analysis. So your research question is number one that you need to consider. Number two is your research design. Is it cross-sectional? If it is cross-sectional, there are some statistical techniques you could use, there are some analysis you could carry out that you won't be able to use for longitudinal study. Cross-sectional study has to do with a kind of research design that you collect your data at a time. Just one shot, you have contact with your respondent or with your target population, and then you have your data, and then you are out. No more contact or no more collection of data from them. That is cross-sectional. It's a situation where you collect your data at once. But sometimes you might also have the reason for longitudinal study. Longitudinal study on this part of the world is a bit not common. It's not a common place somehow, because it involves it's expensive somehow. It's expensive. So when you have cross-sectional study, there are statistical techniques you could use. When you have longitudinal research design, there are statistical techniques, data analysis you could carry out. Now, longitudinal data could be in two forms. Sometimes there may be no intervention. You don't have any intervention. You are just monitoring what is going on maybe in the population, and you are collecting the data at regular interval. And so for such kind of research design, you could be thinking of maybe peer-to-test, you could be thinking of McNemark chi-square, you could be thinking of Cochrane Q tests, multi-level, general linear model, and so on. You can look at growth curve, repeated measures, and many more, depending on what other conditions your data have. So longitudinal data or longitudinal design with no intervention. And then you could also have longitudinal research design with intervention. And a good example of that is when you have randomized control trial, RCT. So the kind of analysis you carry out in that condition is different from the one you carry out if otherwise. And for RCT, you could be looking at general linear model, you can look at difference in difference analysis, you could be looking at multi-level analysis and so many other, set of analysis like that. So, and it could be pure experimental design, it could be quasi-experimental design. So all of those various research designs, they have their peculiar type of analysis that you could use. And then another thing that you will also need to consider before you choose your statistics is the type of variables that you have, type of variable, and the type of your data. Is it numeric? Is it categorical? So it's important to decide, to know whether your data is numeric. And if it is numeric, is it only the outcome variable that is numeric or only the explanatory variable? Outcome variable means dependent variable, and then explanatory, that's the independent variable. So you need to identify them. You also need to know whether it's both outcome and explanatory variables that are numeric, whether both are categorical, whether one is numeric and the other is categorical. And then if it is categorical, is it binary, is it multinomial, and so on. So all of that, they are very important. And then your sample size also influences your choice of statistical techniques. If your sample size is large, you have some choices. If your sample size is small, then your choices may be different from what you will do if you had had a large sample size. And then the nature of your data, I've talked about this, binary data, if it is binary, if it is multinomial, and if it is count data, that is, if your data is numeric, is it count or is it continuous data? Count in the sense that whether it's discrete or is continuous. And then another factor that determines the type of analysis that you carry out is whether your data satisfy statistical assumptions. Is it normally distributed? There are statistical tests you use if normality assumptions are satisfied. Otherwise, you can't use them. You have to use another set of statistics. But then there are some of them that when you use a non-parametric statistics, your power of precision is reduced in a way. So another statistical assumption is equality of variances. If you are looking at two different groups, comparing groups, you might want to look at equality of variances, you might want to look at whether there is over dispersion or not. And there are many more statistical assumptions that might have to be considered before you choose your statistics. And sometimes when the assumptions are not satisfied, another thing you could do is to transform your data where necessary. Now, there are different levels of data analysis that you could carry out. Having understood all the conditions, you have understood your type of research design, so there are different kinds of analysis you could carry out. Levels of analysis. You begin from the univariate analysis, then you do some bivariate analysis as well, and sometimes, largely, bivariate analysis are inferential. You could also do some univariate analysis that are also inferential in nature. So, and then you also do multivariable analysis, and where necessary, you do multivariate. There's a difference between multivariable and multivariate. So, for univariate analysis, you want to describe your data, descriptive analysis. If it is numeric, you want to talk about the mean, that is the measure of centrality. And then as you are looking at the measure of centrality, you want to look at the measure of dispersion alongside. And a good example is standard deviation. Then you could also look at median. Median is the non-parametric alternative for mean. So you might want to do that if you discover that your data is not normally distributed. And then you want to look at percentage distribution, which is part of the description, the descriptive analysis. Then, like I said, sometimes you could do some inferential analysis or inferential statistics in univariate analysis. And that is the good example is one sample data. And there are some other ones that you do inferential statistics with univariate analysis. For bivariate, we do cross tabulation if your data is categorical. We do t-test, either to independent sample t-test or peer t-test and what have you. And also you could do ANOVA, you could do simple linear regression for bivariate. And for multivariable, that's when you have one outcome variable and you could have multiple independent variable, explanatory variables. So in that case, you use multiple linear regression. You use logistic regression. That is, if your outcome variable is binary. You could also use, so if your outcome variable is binary, you use binary logistic regression. If your outcome variable is in multiple categories, more than 2 categories, then you use multinomial logistic regression. And if it's in ordinal form, then you use ordinal logistic regression. So you can also use multivariate, you can also do multivariate analysis, like general linear model, like MANOVA, that's multivariate analysis of variance. But this one has been generally, replaced with general linear model. It's not often done again these days. I mean, in the modern statistical analysis, it's been replaced with general linear. So, yeah, these are some of the descriptive statistics you could do. You could present them in form of a table. You could use sum bars. You could use pie chart. You could use bar chart. You can use either column chart or horizontal bar chart. So you could describe your data in various means. So you could these are like you are presenting your categorical data. If it is numeric, you could be talking of presenting your mean and your standard deviation, median. You could present the minimum, maximum, and so on. Now, other univariate descriptive analysis you could carry out if you are dealing with a longitudinal data or a panel data. You could look at trend. You look at trend over time. So, also, that's univariate. So, for bivariate, you could look at contingency table in a way, and with that, you are drawing some patterns. Use percentages, use means across groups. At this point, you are not testing differences, you are not testing associations, you just want to look at the patterns. So you could do this kind of analysis for your bivariate descriptive analysis. Then for the for other descriptive analysis, people look at the measure of central tendency, like parametric, I've mentioned this, and non-parametric, median, and mode. And then while we are analyzing the description, when we are describing the data using parametric test, as you use measure of central tendency, you are also supposed to use the measure of dispersion. And a good example is the standard deviation alongside your mean. Each time you are talking about your mean is an average, and it could, the values, the actual values of the respondents could be less than the average or more than the average. And so, of course, that's what the minimum and maximum will reveal, that this is the minimum, this is the maximum value, but this is the average. So you need the standard deviation to tell us that what is the standardized range of deviation from this mean. So that is what standard deviation would do. So you could also compute your variance, or you you compute the range of the data. So if it is non-parametric, you could look for the interquartile range. You could look at the centers, and of course the centers. You could look at 25 percentile, 50 percentile. 50 percentile is going to be your median. You could look at some 50%. Percentiles. So if you want to look at the interquartile range, and that is a non-parametric approach, a non-parametric measure of dispersion in replacement for standard deviation. So you look at interquartile range, and that is the difference between 25th and the 75%. Another description you could make from your data, this has to do with distribution. You look at the distribution of your data. If it is a continuous data, you could use skewness, you could use kurtosis to look at how the data is distributed. The more advanced statistical techniques is to use Kolmogorov-Smirnov test. That's another example of a statistic that you use to test the distribution of the data. You could use skewness, you could use kurtosis. You can also use histogram with normality curve, although sometimes that one does not give you the most accurate test of the distribution or normality test for your data. So you could use skewness, you could use kurtosis. Skewness of value is 0 is the one considered as that is normally distributed. And kurtosis also, when the value is 0. So the closer your value to 0, the more normally distributed your data is. And the farther away from 0, the more non-normal your data is. And where that exists, you could transform your data. So this, some of this, the picture here talked about whether your data is normally distributed or not. They are dealing with continuous data. If it is symmetric like this, the first chart. So that is, I'm talking about this. Let me use my picker to point to it. Yeah, I'm referring to this. So that is normally distributed. And when you have a result like this, of course, this is achieved using histogram with normality curve. So when you have a result like this, this means this is skewed to the left. And then this kind of result is skewed to the right. So another distribution you could use is when you have your categorical data, when your data is categorical, you could run frequency distribution of it to see whether some responses are more represented than the other, and whether there will be need for you to do some transformation or some manipulation before you go into analysis. So, okay. Sorry, I think the annotation is still showing up. Yeah. Okay. Now, other things you look at when you are, well, I've talked about this. Let me skip this slide. Yeah. So, choosing appropriate statistical method, choosing appropriate statistics. Now, you have your data with you. You have done all the diagnoses, you've run your descriptive analysis. Now you want to begin to do some inferential statistics. Now, if you are dealing with one outcome variable, and the outcome variable is binary. If it is measured once, I want us to understand this part very well. I've combined those various conditions I've mentioned so far, the type of variable you have, and then number of times it is measured, So this number of times is addressing whether it's cross-sectional or longitudinal. So what statistics can you carry out? Now, if your outcome variable is binary, you are dealing with outcome variable only. We are not dealing with explanatory variable yet. If your outcome variable is binary and it is measured only once from your sample or your study population, what kind of statistical test would you be carrying out with this? You could be talking of incidence or prevalence. And how do you get prevalence? You run the frequency of that data. Just run the frequency. It's going to give you the prevalence or the percentage of the various responses you have in that outcome variable. For example, let me use the example of, let me use a very common one in social sciences. I know some of us are not from social sciences. Let's say let's say you are working on healthcare service utilization, and we want to measure it whether someone uses it or not. So it's yes or no. I'm just using that as an example. In the real-time research, you might not be able to measure it that way. You might have to consider other things before you conclude, before you finalize on how that variable will look like. So yes or no, whether you use healthcare services or not. And it is measured once. So when you run the frequency, you'll be able to see what's the prevalence of healthcare service utilization, maybe antenatal care service utilization, ANC. So what's the prevalence? What proportion of the respondents are using antenatal care service? So, and if it has to do with, maybe it has to do with a disease, then, or an event, you might want to look at incidence as well. So if it is binary, you could look at incidence or prevalence. Now, if it is binary, but it's measured twice on the same set of respondents, you measure it twice, and it's binary, you will be doing McNemark chi-square. You could do kappa statistics. McNemark chi-square looks at the difference. McNemark chi-square doesn't look at association in the real sense of it, not like normal Pearson's chi-square. It looks at the difference between the first and the second, and they are in percentages. Then you can also use kappa statistics, and that addresses whether there is agreement. Kappa statistics is used to look at agreement between two different measures, between the first and the second. It may not be on the same respondent sometimes. I mean, you collected your data first time and second time. It cannot be on the same respondent sometimes. Maybe you are studying, let's say you are looking at you are studying you are looking at maybe adolescent communication, maybe communication, social communication. And you want to hear from the adolescent, you want to hear from their parent. You could look at the response, the same variable, you measure it in adolescent, you measure it in the parent. You could look at the level of agreement between the two. And at this point, you'll be using kappa statistics. So that is when you have binary outcome variable that is measured either once or twice. If it's once, you use prevalence, you can run frequency, and that's prevalence. Or if it is twice, use McNemark chi-square or kappa statistics. Now, if your variable is numeric, at this point, we say maybe continuous. Before I move on to continuous, let me give another instance of the binary response of the outcome variable. You know, I just talked about if it is measured once or measured twice. If it is measured thrice, if it is measured 3 times or more, then you will be using Cochrane-Q test. It is not in this slide. You'll be using Cochrane-Q test. Cochrane-Q test allows you to look at variations in the responses at the stage 1, stage 2, stage 3 of the measurement of the variable. So you use Cochrane-Q test. Now, coming to continuous response variable, if it is measured once, well, you could do test of normality, that is just diagnostics in a way. Now, for you to do inferential statistics, you could do one sample t-test. Well, this training, let me say this training is not something we can, everything about data analysis is not something we can achieve in a single training. It's something that we will do, in multiple times, and then it has to involve some practical session. But of course, we won't be able to deal with practical session in this training today. So if we have opportunity of going to practical session next time, then we could demonstrate all of this statistical analysis, all of these tests that we are talking about. So you could do one sample t-test. You just want to compare. One sample t-test compares the mean
sorry,
of your sample.
Sorry, sir. Please let's begin to round up, sir, so that there will be time for questions.
Thank you. Yeah, there are quite a lot to talk about, but I will quickly run through the rest of the slides or stop where I'm able to, where I feel it's a bit convenient to just stop. There are still quite a lot to talk about. So one sample test, you use one sample test when you're comparing the mean of your sample to an hypothetical mean. You want to see whether there is difference in that mean compared to your hypothetical mean. So you could look at mean, standard deviation, you could look at median and interquartile range if it is continuous. And the median and interquartile range comes in if the data is found to be non-normally distributed. And then if the continuous variable is measured twice, then you could be talking about paired t-test. Look at paired t-test. And sometimes, if other variables are involved, then you might not use paired t-test. But at this point, we are talking about just outcome variable alone. So, if it is measured twice, you look at paired t-test. And if it's measured 3 times or more, you look at you use repeated measures ANOVA. Now, what if you have outcome variable and you also have explanatory variable? What kind of analysis do you do? So if the outcome variable is quantitative and you have only one outcome and your explanatory variables are all quantitative, and you also have explanatory variables, number of levels of category variables. So we have both, you have explanatory variables that are both categorical and quantitative. At that point, you could use multiple linear regression. Remember, your outcome variable is quantitative, and you have several explanatory variables. Some of them are quanti, some of them are categorical, either binary or non-binary. You use multiple linear regression. If some of your outcome variables that are categorical are not binary, you turn them to dummy variables, turn them to binary. Then you could use multiple linear regression. So if your outcome variable is quantitative and you have all your variables that are being categorical, and you have maybe at least one of the explanatory variable that has 3 or more categories, then you could use two-way analysis of variance, and you could also use multiple linear regression. But then you have to turn the outcome to binary. So also, if you have your outcome variable is quantitative, and you have your explanatory variable that are both quantitative and categorical, and in that categorical variable, it has 2 or more levels, you could use analysis of covariance. Remember, you have both quantitative and qualitative, and categorical in your explanatory variables. Once we are combining quantitative with categorical, you could use analysis of covariance if you are not running a predictive analysis. If it's predictive analysis, then you go to multiple linear regression. Now also, when your outcome variable is quantitative and it's measured more than once, in that case, with your explanatory variable being both quantitative and categorical, at this point, you use repeated measures analysis of variance, or you use autoregression. And then when your outcome, when you don't have outcome variable, you don't have any outcome variable, but you have the explanatory variable that are both quantitative and categorical. In this case, you will run factual analysis. Now, when it is categorical, you will have to turn the category into dummy variable for you to be able to run factual analysis. But if everything is quantitative, you don't have outcome variable, you just want to do a kind of construct, or you want to do data reduction, you do factor analysis. Well, my time is up. These are different kinds of statistical software you could use for your analysis. I'm going to round up here. And then I gave some examples of bivariate tests, and I put some examples here. So I'm going to conclude the training here. If we have opportunities, we can do more next time. Thank you very much for listening. Now it's time for your question.
Thank you very much, sir. Obviously, quantitative analysis is not something that could be taught easily in a class. And I see this is a very extensive lecture. One of the things we can do, sir, is that we can mark where you stopped, and then we can see if it is possible to organize another time for you to conclude in this session, so that if possible you could also show us some demonstrations. But then at this point, because of our time, we would have to stop. But then let me just read a few questions. Okay, so Matthias almost says, to what extent can a researcher manipulate data before data analysis? Another person says, what is the distinct differentiation between quantitative and qualitative? I think this has been answered in previous classes, so we can skip that. Please, how best can we master the various statistics used in research, particularly for a person with little or no experience? What are your recommendations, sir? Or if possibly, if you can give a step-by-step roadmap of where to begin, where to end the mastering of these statistical tools. Yeah, I think the last question. Let me just read the last question, sir. Let me read the last question so that you can just respond to them together, sir.
Okay.
Yes, because we have just 2 minutes. Oh, okay. Start, then respond to the ones I've read then.
Okay, yes. So the first question, to what extent will a researcher manipulate his or her data? Well, to the extent of the need of your study. Sometimes we propose some statistical analysis when at the stage of proposal, but when you get to the data, well, after the data has been collected, you see something different. So you have to, and in that manipulation we are talking about, it's not in terms of doing some, injustice, doing some maneuvering that are unethical. That's not the manipulation I'm talking about. It's in terms of transformation. If your data is not normally distributed, at that point, you could do a kind of transformation, maybe log transformation, maybe you find the reciprocal or square root or square of the numeric variable. So you could do that, and that has to do with that affects continuous variable. And if it is categorical and you discover that some samples are too small, because when you are doing some of this analysis, there are some assumptions that you have to follow. If the assumption is violated, your estimate is going to be biased, and so your result becomes unreliable. So you could collapse some of the rest categories if you discover that some samples are just too small. Like, for example, you use marital status and you want to see how it influences maybe your outcome variable, and you discover that out of a sample of 300, only 5 are single, and then only a few, many are married, then you have many that are widowed. So for that single, you might have to combine it with another variable, and you have to indicate it. So when you are manipulating your data, no unethical practice. You do it objectively based on what the data requires. That is, I think I've answered that question. Then the second.
Yes, I continue, sir.
Yeah. What was the second question about?
All right. So the question is about if one wants to get introduced to this quantitative analysis tools, where can one start from? For instance, for a lay person who wants to come into quantitative analysis, where can they start from?
Well, the person has to start from a program like this. This program exposes you to things you need to do, some rudiments. You need to have the foundation first of all. If anybody wants to come into quantitative analysis, you need to have some. You don't have to go deep into all the statistical formula. but know the principles behind them, know the do's and don'ts of using some of these statistics, the assumptions, and then the person also needs to know how to diagnose its data. And of course, you must have a software that you are interested in. Without a particular software, you can't do a good quantitative analysis. The era of manual analysis has gone, so we have a lot of software that can help us. So start by learning some of this software, play with them, use them when you want to do it, play with the analysis, seek audience from experts, seek advice, guidance from experts. Yes.
Thank you very much, sir. I think there's one last question that I feel may be important, and sorry. Okay, so what is the implication of the data diagnosis? If you check for the assumption and your data doesn't meet those assumptions, does it mean you can't analyze the data? And that is the last question.
Well, I have given some of the, I've addressed those in the presentation. When you check the normality of your data, or sometimes not even normality, it could be that you check for other assumptions. If the assumption is violated, where possible, you could do data transformation. If it is numeric now, you could do data transformation. If it is categorical, you could do some collapsing, like I said the other time, match some variables. But where it is not possible, for example, I talked about marital status the other time, and all the responses you have is single and married. And out of the 300 sample that you have, 5 are single. The remaining 295 are married. You can't use that variable for that data. So just remove it. That is one step you could take. So where the assumption is violated, it's either you transform your data where possible, or in some cases, you drop that variable, like the example of marital status I gave now. When you do a kind of chi-square analysis on that, it's going to violate the assumption of having not less than 5 expected counts in 25% of the cells. So, but if in other cases, if the assumption is violated, then you are left with a choice of using another statistical test. There are alternative statistical tests you could use that will accommodate that non-normality that you have carried out. So you need to know the parametric and then the non-parametric equivalent of all the statistical tests. So that's what you do.
All right. Thank you very much, sir. I sincerely apologize that we are a bit above the time, but then thank you very much, sir.
This is, of course, for taking much of it.
I'm sure everybody here already, we can all agree that we were just taught by an expert in the field. So I want to say thank you, sir, for this. Like I said, we'll discuss and arrange for another time to conclude this session. So please prepare to, so we'll let you know in subsequent editions when that session will be. So thank you very much, sir. Thank you very much, everyone, for coming. Thank you, Professor Okung. I don't know if you are able to just say, to help us close so that we can leave. Ma'am.
Yeah, thank you once again. I would truly want to thank our resource person, Dr. Mobolaji. Really grateful for honoring our invitation. We would work towards this. Even myself, as I was sitting there, my head was just doing bang, 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 that, I don't even know anything. I was just thinking, all this paper that I've been doing analysis, I hope I've not been using wrong analysis. I'm really grateful. And thank you to every single participant, especially those that have stayed with us from the beginning. I'm looking forward to having you next week. I think I'll be speaking next week, right? Have a wonderful day, everyone. And thank you, Dimeji and your team. It's been brilliant having you handle this. Have a good day, everybody. Bye.